You're welcome again to Seremba Online School. My name is Mr. Katerega Fred. This is going to be a continuation from where we stopped in our previous lesson, and specifically sound waves. We are going to talk about them today in details. So what is meant by sound waves? Sound waves are waves. These are waves produced when particles of the medium are set into vibrations. Are you getting that? In case particles of the medium are vibrating, you will hear some sound. But this is sound, it can travel. Sound travels in all states of matter, okay? It can travel in liquids. It can also travel in solids and gases. Everywhere, in all states of matter, we can have sound, because all the states of matter have particles, and those particles can vibrate. Are we together? As long as vibration of the particles of the medium takes place, sound must be heard. So what are the properties of sound waves? Some of the properties of sound waves. Okay? 1. Sound waves are longitudinal in nature. If you recall very well, when I was talking about longitudinal waves in one of our previous lessons, I told you that the longitudinal wave is a wave in which the particles of the medium vibrate parallel to the direction of propagation of the wave. And I remember giving you an example of sound waves. Therefore, sound waves are longitudinal in nature. Sound waves is longitudinal in nature. That is a property, longitudinal in nature. And then 2, sound waves need a material medium for their transmission. When there is no medium for transmission, sound is not heard. Okay? Another property, sound waves need a material medium. They need a material medium for their propagation, for their transmission, or for their propagation. Okay? I can give you an example. Like sound waves, when they are traveling through a medium called air. Okay? If they are traveling in air, you remember very well, they will form the compression region and the rarefaction regions. Okay? I don't want to go into details there because we talked about it in longitudinal waves. So another property, also sound waves are reflected. True, sound can be reflected. You have ever heard about the reflected sound, what we term as an echo. Sound can be reflected. Also, sound can be refracted. That is another, is a continuation here. Combine them together. It can also be what? Refracted. And also, sound can be diffracted. Even sound can undergo interference. Okay? It can also be diffracted. And then sound can undergo interference. Yeah? Sound waves are always interfered. Sound waves can undergo interference. Are we there? Now those are some of the properties. But what do you need to know? This is what I want you to know now. Ask yourself, how does sound travel from the source through air? Okay? That's a question. In the case, it is a simple question, okay? Explain how sound waves travel, how sound waves travel through air. Okay, you should be in a position to know. Remember, in this process of traveling through air, for example, now, if assuming that you are seated in a class, I'm talking, even if somebody seated in the corner is able to hear my sound, how does sound reach that person? Okay, because of this air which is present, air consists of invisible molecules you cannot what? See. So those air molecules are caused to vibrate, they vibrate. So as you produce sound from the source, the vibration of one molecule is transferred to another molecule. And in the due course, there is energy transfer. So in other words, energy is transferred from one particle to another particle. So this neighboring molecule, as it vibrates, it is going to transfer the energy to the next molecule. It also transfers to the next molecule. So you are going to find out that sound is propagated in that process. Are you getting it? Due to the vibration of the neighboring molecules, as the neighboring molecules also cause the next molecules to vibrate until when sound reaches its final destination. Briefly, so I want you to explain that. You write it, so you will send your feedback on our WhatsApp group for marking. I want you to sit down and you explain for me how sound waves travel through air. Briefly, I have given you a brief explanation there. Then we can continue to, we have said that sound waves cannot travel when a medium is not there. A good example, sound travels through air. Like as I'm talking, my sound is traveling through air. That means that air is the medium of transmission. Now, let us go to an experiment to show that sound waves need a material medium. Okay? That is the diagram. It consists of this external circuit you see. K is the switch. This is the battery. This is an electric bell which has the hammer and the gong. We shall see. If you want sound to be heard, this hammer must beat the gong. It should strike the gong. When it hits the gong, we hear some sound. This is the bell jar. And we also connect to the vacuum pump. Then, have you drawn that diagram clearly? If we have finished drawing the diagram, then we can go to the procedures of the experiment. Okay. Now, the electric bell, these are the procedures. The electric bell, I think where the electric bell is enclosed in a bell jar. The electric bell enclosed in the bell jar. I sing it. The electric bell enclosed in the bell jar is connected. I sing it is connected to the battery, because it needs the battery which acts as the source of its EMF. This electric bell you are seeing enclosed in the bell jar is connected to the battery like you can see. Now what next are you going to do? You have to close switch K. Are you getting it? The switch K is closed. The switch K is closed. Now when you close switch K, what will you see? Okay? You are going to see this hammer hitting or striking the gong, and the loud sound is heard. The switch K is closed. The switch K is closed, and the hammer is seen striking striking the gong, producing a loud sound. I sing it. Switch K is closed and then loud sound is heard. You will see this hammer hitting the gong, then you hear some sound. Remember, this is an experiment to show that the sound waves need a material medium, and the material medium in this case is air, because inside this bell jar we are having the invisible air molecules you cannot see. Then the next, remember, you have heard a loud sound. So if you connect now this vacuum pump, okay, when you start removing this air gradually, slowly by slowly, from this bell jar, what will you notice? You will notice that the sound you had originally keeps on reducing, keeps on diminishing, dies away slowly by slowly. Why? Because you are removing the air from the bell jar. Also, you come here, you write and you say, when the air in the bell jar, when the air in the bell jar is gradually, you know, something which is gradual, it's a slow process. When the air is in the bell jar is gradually removed. But how do you remove it? By means of this vacuum pump. That's why you see this arrow to the vacuum pump. This is where the air is going to pass. Okay, you connect that vacuum pump. When the air in the bell jar is gradually removed by the vacuum pump, the sound heard. Are you seeing it? Because this is an experiment, we expect you to observe. In science, we observe. Okay? So, the sound heard keeps on diminishing. The sound heard keeps on what? Diminishing. Or you can say the sound heard keeps on reducing or dies away. The sound heard dies what? Away. What I mean here, it will not die away completely, but at the first sight you heard loud sound. Now the sound will start reducing, it will start becoming low. Are you getting it? Then the next step, are we there? Now you are removing the air slowly by slowly. That is gradually removing the air. Sound is dying out slowly by slowly. Now what if you remove the air completely from the bell jar? Are you seeing it? What if you remove the air completely from the bell jar? You will see this hammer striking the gong or hitting the gong, but no sound is heard. Why? Because the medium through which sound is transmitted is not there. Are we together? Now you have completely removed the air from the bell jar. What do you expect? Even if you see the hammer striking the gong, no sound is heard. You write that step also. You come and you say, when the air is completely removed, when the air is completely removed. Are we together, class? When the air is completely removed, what happens? So those are the marking points we need there. What happens when you remove the air completely? The hammer is still seen striking the gong. Or let us just say the hammer is still, let us not use this language, the hammer is seen hitting, H-I, is seen hitting the gong. The hammer is seen hitting the gong, but no sound is heard. You can imagine. You are seeing the hammer hitting the gong. You expect to hear sound, but no sound is heard. Why? Because the air through which it is transmitted has been removed. Now, on returning the air, on returning the air, on returning the air into the bell jar, on returning the air into the bell jar, now when you return back the air, you will hear sound because now the medium is back. So on returning the air into the bell jar, then sound is heard. Is heard. So make a conclusion here. Sound is what? Heard. Therefore, this shows that sound travels through a material medium. Through a material what? Medium. In other words, in conclusion, that shows that sound waves need a material medium for their transmission. Okay? That one is done. Hope you have written all those steps. I've given the conclusion and the diagram. Then lastly, I want to talk about the speed of sound. Speed of sound in air. You know, when sound is moving in air, it is moving at a certain speed, and there are some factors which affect the speed of sound in air. What are those factors? So, factors affecting the speed of sound in air. Factors affecting the speed of sound in air. We have the first factor, we have temperature. So, how does temperature affect the speed of sound in air? Are we together? Because I told you that when sound is traveling, we are expecting particles to be vibrating. What you need to know, that the kinetic energy of the vibrating molecules is directly proportional to the temperature. Meaning that when the temperature of the molecules which are vibrating increases, that one in turn increases the speed of the molecules. Therefore, increase in temperature increases the kinetic what? Energy of the molecules, thus increasing the speed of the molecules. Increases the speed of sound in air, and decrease in temperature reduces the speed of sound in what? In air. Are we together? Then another factor, density of the medium. Density of the medium. By the way, the speed of sound is faster in denser mediums than less dense mediums. Do you know why? Because in denser medium, are we together? The particles are closely packed. And when the particles are closely packed, that means it is easier for the particle to transmit sound from one particle to another as vibrations are taking place in that what? Medium. Therefore, the speed of sound is faster in denser medium, than in less dense medium. Medium. I've given you why. An example there. Okay? Because the molecules in the denser medium are closely what? Packed. So they are close to each other. Therefore, sound will be transmitted faster than when the molecules are somehow far apart from each other. So when they are closely packed, the transmission is so what? Fast. So lastly, I can give you another factor. We can talk about like wind. You know, also the direction of travel of the wind matters. Are we together? The direction of travel of the wind also matters. So in case the wind is traveling in a particular direction, that's where also the speed of sound, the speed of the wind, when you add it on to the speed of the sound, then that one it increases the speed of sound in the air. Wind also matters. And in case sound is traveling in that direction and the wind is moving in an opposite direction. That one decreases the speed of sound in the air. Therefore, the speed of sound in the air increases if the sound is moving in the same direction to that of the wind. And the speed of sound in the air decreases if sound is moving in the opposite direction to that of the wind. Okay? Those are some of the factors affecting the speed of sound in air. For more factors, already you have the notes we sent in soft copy on the WhatsApp group. So I beg you to stop here. I remain Mr. Katerega Fred. We shall continue from there next time. Thank you for watching.